lastly, we will touch upon forecasting equipment usage. Now, in case if you stop receiving the video or audio, just alert me so that and possibly. Right. So just some of the fundamentals about acquiring scheduling skills. You will learn scheduling by doing and not just by listening or reading. So that's highlight that there's a bit of a practice which is required. Skills acquired to help you complete projects to cost, time, and quality targets could be applied in various types of projects. So these skills, which we covered in our first session and which we are building in some of the following sessions, are quite like in nature, and these could be applied for scheduling any type of project, be it residential, manufacturing, commercial, industrial, engineering, business, or design projects. Now, there are a range of scheduling software that are available these days. So you don't have to go through that nitty-gritty details of doing CPM analysis and calculating the forward pass and the backward pass. Most of the software will do these sort of calculations for you. So the software like Primavera, Microsoft Project, Asta Project, Sage, or 4D modeling software such as Synchro, Navisworks. These are quite sophisticated software tools that could help you plan your project and also for effective monitoring and control. The thing is, it's important because these are very feature-rich projects. So software, so you could select the tool of your choice and then try to become a master in using that tool. Now, having said that, using computers without a fundamental knowledge of scheduling will not be so beneficial. So if you don't know what, for instance, a resource leveling is, how do we manage resources, what is the theory behind it, just clicking a button and getting an output may be meaningless and possibly not very beneficial. So that's why we are trying to start from the scratch and go through it. Now, before we delve deep, bit of a theory. I'm sure you might have gone through this diagram from Patrick McLeamy, the level of influence diagram. The key message here in this diagram is that at the beginning phases of your project, so here you can see the project stages starting from prelim designs to schematics to detailed designs and then construction documentation and so on and so forth. So the line one here is indicating the ability to impact cost and functional capabilities, which is maximum at the prelim stage when the design documents are live. So you can change about your floor plans without having any impact on the project cost. So that's where a lot of thinking, analysis, simulations should be taking place. The line 2 here indicates the cost of design changes, again, which is minimal at the beginning of the project when the design documents are live. You could do any changes to your design without incurring a huge cost. But as we move along in the project life cycle, any changes in the functional capabilities or any changes in the design could wreak havoc. Now, the problem in our traditional procurement methods, which is indicated by the curve 3 here, is that a lot of the thinking and analysis, particularly from viewpoint of a production side and from realizing the designs into actual finished product, takes place after the bidding stage when contractors get on board. Now, mind you, the contractors have got a very rich experience on the production side, and then after getting on board, they get into an exercise of value engineering, which is essentially involves cutting down the scope to bring the project back to its original cost and time targets. And what we are seeing within our industry is that realization that this is not the most efficient way of working, and we are trying to push this peak slightly earlier through more integrated procurement strategies. So we could do our thinking and analysis with regards to production a bit early in the project life cycle. So you might have seen new procurement routes, things like design build or integrated project delivery, which encourage more collaborative design and delivery right from the beginning of the project. So in the first session, we did review that our ultimate goal, both from a design and production perspective, is to get to the top right quadrant, which is to have projects which are properly planned and properly executed. Now, having said that, a vast majority of projects fail to achieve these targets because it's easier said than done. We would like, in an ideal world, our designs which have sufficient detail so that they could be built and produced, and also we would like to produce which are according to the specifications and the design, so completing this loop. But having said that, this becomes difficult, giving in view that the construction end users are quite complex. The construction and the owner organization is usually not a single entity. It could include facility users, owners, facility managers. So if we are talking about a school construction, that could involve teachers, local councils, the end users of the building, the design engineering organization, the construction management organization, the building organization, subcontractors. So sometimes it's very easy to lose the big picture and the big vision. And as a result, we may end up in situations where projects have poor problems with both planning or execution, or one of the aspects, either the production side or the planning side, was lacking. So we saw in our first session a few example case studies of projects which were badly done. One example is Wembley Stadium, where here you can see the initial cost was 200 and the final delivery cost for the client was 767 million pounds. So obviously owners are not very happy when they are getting a service like this from the industry. Likewise, Scottish Parliament building, we reviewed this case study in our initial session. Also, if you read through the Sunday newspapers, you will see quite a few articles highlighting problems with the construction infrastructure projects. High Speed 2 has been in the news recently, and historically, a lot of the construction projects fail to hit the top right quadrant that we talked about early, and we see quite a few. Now, it's not that all the projects are like this. We have got quite a few good examples as well. So a reflective question here. You are being brought in to rescue a project which is in total chaos. Plans have not got enough details. Site managers do not understand project plans and specifications. Owners keep changing their mind. Subcontractors, they never show up at right place and right time, and they are delivering inferior quality work. The suppliers are not delivering material on time. However, suppliers are complaining material is not being ordered with right lead time. So it looks like a project which is being managed not in a very good manner. So what are high-level strategies could possibly be used to rescue this project? So any thoughts you would like to share with the rest of us? Okay, so looking into your team structures, looking at highlighting what is going wrong, maybe you could do some sort of like a root cause analysis, and that could be one starting point. So you could do something like a higher level PODC review. So here we highlighted some of the key fundamentals of project management effort, which for P referring to planning, organizations, direction, and control. And very often when the projects are failing, we have got issues. Either there are problems in planning, or we are not properly organized. So maybe looking at the way communication is done, or lack of direction, or leadership, and also the control. So having a look at this PODC review, often when things are going wrong, it's very easy to start with blaming. So putting, for instance, subcontractor so and so is not delivering in time. As a result, there's a knock-on effect. As a good project manager, it is important, rather than blaming, to take a responsibility and overall control of the situation, because blaming leads to a negative sort of a culture, which is usually not conducive to achieve project management objectives. We could do a root cause analysis. So trying to get to the bottom of the matter, what could be going wrong. There are a number of different tools. One is, for instance, a 5 why analysis. So you keep asking why question till you get to the bottom of the matter. So for instance, if the materials are not being delivered, you keep asking the question, why is it not being delivered? So perhaps it has not been ordered at time. Why it was not ordered in time? It was probably not highlighted to the relevant person. Why was it not highlighted? So you keep asking the why question to you until you get to the root of the problem. Then problem solving approach and ensuring job specifications and schedule is clearly communicated. So one can start with the high level overview, highlight the sort of actions which are required, and take it from there. Now, one question and one argument which is often used to justify the poor performance and productivity of construction is that construction projects are very different, they are unique. So my question here is, what you think, what makes management of a construction project different from managing non-construction projects? What would you say are the key differences in the construction management versus maybe a factory-based projects? Right. So issues highlighted include things like maybe every project is unique. Okay, now this is a viewpoint which is being challenged by a number of people. So even though projects are unique, there are quite a few similarities between each project. There is an issue of liabilities, which is highlighted. Construction repeatable. Now, again, we can take this viewpoint that every construction project is unique, given the geography and the location and the soil condition it is being constructed on, may be unique. But we can argue that there are a number of components within a construction which are repeatable. So, for instance, the walls and the windows and a lot of furnishing. So there is a possibility for us to carry knowledge from one project to another kind of projects. So we can see a number of things which make the projects different. Firstly, nature of the projects. Projects are unique and unrepeatable. They are temporary. They are constrained by time, quality, and money. So is the case with other projects as well. Projects involve many conflicting parties. So it's interesting the way, and the word conflicting is used very often, the way our procurement contracts are set. It makes the clients and the contractors and the designers a bit of a conflicting situation where everyone is trying to pass the risk onto the other side. And many decisions are made as solely on experience. So again, that's an issue where we rely quite a lot on the tacit knowledge. A lot of the construction knowledge is embedded in the brains and experiences of construction professionals, which is not well documented. So very often we have got situations where people leave and their projects suffer quite heavily. And then there are industry characteristics such as extremely fragmented with many small specialties involved. So a number of different subcontractors, SMEs, and small scale construction companies comprise a vast majority, over 90% of the construction industry. There is intense competition and a high failure rate. And as a result of intense competition, contractors may be competing with each other at a very tight profit margins. And as a result, a lot of businesses go out of business very soon. Very tough environment, rapidly affected by recessions, little research and development expenditure. Construction is not and usually classed as a technology laggard industry. They're a bit slow in adopting new technology. Confidentiality and lack of information sharing, again, related to the sort of a legal conflicts which could potentially arise. So very often we see construction contractors even reluctant to share Excel spreadsheets and bare minimum sharing of information to avoid any potential lawsuits in the future, or slow to adopt new technologies. And then as an industry, we are facing increasing challenges, increasing regulations, environmental safety. There are new advances in materials and equipment, which bring new opportunities for us to improve our productivity. Within construction, we often deal with tight budget, less time, yet better quality is demanded, rising cost and lack of skilled resources. Right, so this is some factors which make a construction project slightly different from the way projects may be managed in other industry sectors, but this is not to justify the problems which we have historically faced in construction, which relates to the problems with productivity, the cost and time delays, and industry is under intense pressure to improve the delivery. Right. So when we talk about project management effort, it's usually very broad. So I think the slide is not clear, but it's just to highlight the various knowledge areas which are covered. So if I start with which aspect of a project management effort deals with defining contracts and choosing a contractor to do work for the project, that would be the procurement aspect, right? So keeping everybody working toward the same goal and dealing with the changes. So maybe perhaps integration management, budgeting your project and tracking the money you are spending. That would be the cost management. So these are various aspects which are covered, even though we are focusing a bit more on scheduling and cost, but it is important to be aware that the total project management effort is much broader, getting the people who will do the work and keeping them motivated. That may be part of the human resource effort, planning for things that could happen, positive and negative, and dealing with them as they arrive, when they do. So I think that maybe part of change management, or making sure that you build the right product and that you do it is as efficiently as possible. Part of the maybe scope management, figuring out who should talk to whom to keep everybody in the loop about your project. So that would be communication, estimating how long you need to do your project and making sure you get it done by your deadline. That will be a part of the time management effort, and defining the work that will and will not be done on the project. That will be part of the scope management. So we see that there is a wider effort which is necessary to ensure that the project meets its targets. Now, one of the key aspects that we are focusing on in the initial sessions is to understand the importance of time. So here we are showing the annual interest rate of 9% and the effect of time delays on construction projects. So the question here is comparing the cost of interest resulting from a 1-month delay on a 75,000 project versus a £500,000 project. So if bankers have given a loan at a 9% interest rate, what would be a cost of a 1-month delay only in interest charges on a 75,000 versus a £500,000 scheme? All right, so you could see from this table for 75,000, that is fairly not such a huge amount, but as your project budget or scope increases, in case of a £500,000 project, we are only paying 37,500 to the bankers for a 1-month delay on a project. Now, this does not include various indirect costs and others, but the point being made here is that the any delays could be very, very costly. Another question, a proactive construction manager saved a month on a £10 million residential building scheme, leading to an additional month of apartment rents for his client because of an early handover. So we are talking about a construction manager who managed to save 1 month from the program of a £10 million. So what is the interest which he or she would have saved for his? If you could see the table and could identify how much would be the interest savings. So rental benefits and due to early handover, possibly savings as a result of a less indirect cost because we don't have to pay employees and site staff for an extra month is just another bonus. But what would be the interest savings in this particular scenario? So yes, so and the total interest saved would be 75 grand. So highlighting the value that time is very important. So we will be looking at a number of different strategies which are often used to save the time. Now this, we would like to touch upon a very good book by Stephen Covey, not very construction focused, but he has highlighted the habits of highly effective people. And he basically divided time into 4 quadrants. And quadrant 1 is where we focus more on the urgent tasks, and if we manage to get time, we start looking into the important tasks. So this may include like responding to the daily emails, responding to the change orders, any queries coming from the site, things of those sort. Quadrant 2 is where our effort is not so much on the responding to day-to-day urgent, but highlighting what are the important things for the project and focusing our effort on those. Quadrant 3 is where we are spending bulk of our time in urgent things which are not so important, and quadrant 4 is where we are focusing on not urgent. So based on this, as an effective project manager, which quadrant you should be spending maximum time in? So which quadrant would you think one should be spending most of their time? Yes, thank you. The quadrant 2 is the answer. This is where a lot of strategic thinking is taking place. We're looking at the bigger picture, and basically scheduling is involved in this quadrant 2. So you're not looking at day-to-day queries, which is often referred to as quadrant 1 is often said to be sort of like a firefighting sort of a thing, a day-to-day response. And this is where we see a lot of managers spending bulk of their time, and as a result, they have a burnout. They spend their weekly, maybe up to 70 hours working through it, and still no one is happy because perhaps the processes are not set properly, and as a result, there's too much of a confusion. If we see, we were talking about Wembley Stadium, and there were about 14,000 change orders. Now, dealing with that sort of a huge workload resulting from this lack of confusion would create a lot of urgent issues which will occupy most of the time. So the focus is not to respond to the change orders, but to get to the bottom of the matter. Why are we getting so much change orders? Is there something wrong with our design? Are we not communicating? And focusing on things which are really, really important. So a key message that we can learn from this very good book is that as a project manager, we should be spending most of our time in the quadrant 2, where a lot of scheduling or strategic thinking is taking place. So responding to the questions why, where, when, how. There's another advice, I guess, from a study from APM, suggesting how an effective project manager should be distributing their time. And the suggestion here you can see very clearly is that while you're managing a project, you should be focusing most of our effort in thinking ahead. Again, the quadrant thinking, where you are anticipating what is going to happen, what are the potential risks, and getting everyone on board. The planning and working to cost and time targets, maybe the quadrant 1 activity could be taking maybe 25. This is just a suggestion, not any scientific research, but based on anecdotal evidence. And maybe communicating with others could take another 25%. But the key thing is very often this is an aspect, the strategic clear thinking, which is often missing from a lot of our project managers' daily schedule. So this is important. Now, when we talk about new tools, new project management software, for instance, 4D planning, we will touch upon it. It helps us increase our time in this sphere, because previously we would be spending a lot of time just investigating what has happened previously, but now with very good visualization we have a clarity, so we can spend more time exploring different what if scenarios and different simulations. Right, so here is a question asked: best project schedule is the one which gives you the quickest timeline. So would you agree to this statement? So a schedule which would help you achieve your projects in good time, would you class it the best schedule, or there are other critical success factors and KPIs that you will be taking into viewpoint. So would your answer be yes or no? There are other things that you would like to? Yes, so I think it is the point being made here is that time is not the only factor which is important. You have to keep in view the project golden triangle. So there are other considerations like the cost, the quality, whether it is, so if you do something very quickly but of a poor quality and you have to do a rework, then there's no point to it. You may end up costing a lot much more time and cost, leading to poor image. Right, safety. So so just time is not the only consideration, and one has to look at the KPIs specific to a project. Now, when we talk about construction management effort, we often refers to 5 M's. Can you highlight what are those 5 M that we refer to, which are central to management efforts? So here, one, to get you started is machinery, which is very critical. And what are other 4 M's that are critical to management effort? Yes, so manpower is another thing. We have to manage our resources. We are working with a limited amount of laborers and machinery. We have got materials which are important. And for money, we are working with typically with a limited amount of budget. And then management, which could include things like quite a broad financial cost, material, equipment. Right, so you have to keep the big picture in view. Right, so as a project manager, very often you have to make decisions where you have to keep a balance. So we have been talking about different critical success factors, and time is not this only factor that has to be kept in consideration. There are other things such as quality, the cost, and sometimes we have to compromise between these 3 or 4 or 5, depending on the project dimensions, to get an ideal situation to a problem that we are facing. So here we are talking about different scenarios, and here you have to see in a traditional project management golden triangle which dimensions have been compromised. So the scenario here is you decided to invest in a house refurbishment project. Time duration of the project was 4 months. Refurbishment project is running late, kitchen is still not refurbished, and you already have exhausted your allocated budget of 30 grand. You decide to sell the house even though it was not complete. So in this, which aspect has been compromised and which one has been achieved? Right, so here you have decided to not to exceed your budget. So you have decided not to compromise your cost target. So you have had an allocated budget of 30 grand, and even though you didn't complete, but you still stick to your given budget. So you have not cost compromised on your cost, but in this project you fail to achieve your time, and also we would say the quality, because the idea was that on a 30 grand budget the entire refurb would have been completed, which was not the case. So even though you in this case the preference was given to cost, while the other two aspects, the time and quality, were compromised. Now, in this situation, which aspects would suffer? So clients keep on changing his requirements. Project scope was blown out of proportion because client could not decide what they want, and you are not meeting the client to discuss the project. So in this sort of situation, what would your thoughts would be on the golden angle of cost, quality, and time, possibly in such a situation where projects are having late in the life cycle design changes and the scope is yet not determined? I think it's fairly obvious to say that all dimensions will be compromised. This project is not likely to achieve any of its cost, quality, time targets. Moving on, you have performed 30% work and already blown 79% of the project budget. Now you go back to the schedule and you try to reduce the number of tasks from the project to save the money, right? So in this particular case, which dimension are you compromising on? So we are compromising the quality, perhaps reducing the scope of the work, just to ensure that maybe you could hit the cost and the time targets. The hospital construction project was due on February 2020. You could not manage the deadline. Now you're negotiating a new deadline with the project sponsors. Now, in such a case, when you fail to achieve the time targets, it has a knockback, and it's very likely that your costs will go up as well. Very often, time and cost have a positive correlation. Now, quality is another aspect. There's not enough detail, but right. So we have to keep these things in perspective. Now, a reflective question here. Your friend is extending his house and have asked for advice on appropriate scheduling system. So they have heard about different software and different scheduling systems. What factors would you consider while selecting an appropriate scheduling system? So which scheduling system would you recommend? Maybe a very simple check sheet, or perhaps just a daily to-do list, some sort of manual approach, or would you suggest that they use a bar chart, or would you suggest they use a magnetic boards on site where they could see, or would you suggest a more sophisticated 4D planning? So what would be your key factors when you suggest an appropriate scheduling system to your friend? Okay, so I think that is the suggestion is either a bar chart or a Gantt chart. Yeah, so sort of things that you have to keep in perspective is maybe the size. Now we cannot have a very heavy duty system which is very resource intensive, very difficult to update. So given if it's a simple project, as it's just an house extension, perhaps you may not need a very sophisticated high-end software, but for more complex schemes, you may require to go with the more sophisticated software. Maybe you can look into owner and architect requirements, if what is their previous experience. You can look into complexity of the job, right? So it's not always that most powerful software tools are always best for the job. It depends on complexity and nature of the job. Technical literacy, because as we discussed, schedule is a live document. It's not that you develop it once and forget it. This is something you will be referring to and tracking maybe on a daily basis. So have those people who will be operating that scheduling system, have they got the technical literacy and the will and the motivation to use it? Have they got the time requirements to operate, and maybe you can look into the critical success factors, the functionality, flexible, is it understandable, management commitment to make it work, and always, as with any new technological innovation, you look into a broader picture like people, process, and technology, which could provide the building blocks. And so looking at those, you have to keep those factors, and I think that's the right choice to go with maybe a simple CPM based scheduling, and then maybe a bar chart which could be regularly updated. Right, so we did talk about managing time and developing the bar charts in our previous session. We will be building on that discussion in this, and in this bit of our session, we will talk about how we could use our bar charts to forecast the cash flow. So this is often referred to as a cost-phased budgeting, or drawing a planned value, or we will be talking about project monitoring and earned value analysis, where this is referred to as budgeted cost of work scheduled line. It basically tells us what is the cost of associated with the work package or a task we are trying to achieve. So for the project shown below, we will be doing a practical example, and you are expected to create a time-phased budget and draw a graph showing a cumulative and baseline budget. This graph is also known as a project cost baseline, or also known as a planned value, or if you're using a project management software, and budgeted cost of work scheduled. Plan value is an important tool to determine the cost schedule variances as the project is implemented. So when we will go to project monitor control, we will see how we monitor our costs. Where here we will be looking at how do we draw a baseline cost. So the project network is given, and for you, the CPM analysis and computations have been done. So your task is to create a time-phased budget and draw a graph showing a cumulative baseline spend. So here we don't have to do, but I will just refresh your memory. So here, and this box is referring to the duration. So the block A has a duration of 4 weeks, and block 5 has a duration of 5 weeks. And these arrows are telling us the precedence relationship. So C can only begin once A has been completed. Now we did discuss this is refers to as early start time, and this box over here refers to as early finish, and this box late finish and late start. So we start from 0 and add the duration, which is 0 add 4, which gives us the early finish, and then which comes here, and then we add the duration and gives us the early finish. And F is a merge activity, and we did talk about we take the largest of the three. So either we could have chosen 8 or 10 or 8 to be placed here, and we would be choosing the largest value 10. So so the forward pass and the backward pass has been done for you, and based on this we can see the float has been calculated. So the float is calculated by subtracting the box at the top from the box at the bottom. So 10 take away 10 is 0, which is telling us that this is a critical activity. Again here 10 take away 10 is 0. Here you can see 10 take away 8 is 2, so this is a non-critical activity. 5 take away 4, so it's a non-critical activity, and this is a non-critical activity as well. So we can see that within this our critical path comprising activities with 0 float is B, D, and F. However, this is not the question which is asked. The question is that to draw a time-phased budget. So we have been given the cost breakdown. So for block A, the cash flow will be grand per week. So we will be receiving a check of 10,000 from the project sponsors in week 1, 10,000 in week 2, 10,000 and 10,000. Now we have to do the tables to help us draw the project PV line and see how it is drawn. So the total budget for activity A, we can see, is £40,000. For activity B, we can see the total summation of all the activities comes to 32 grand. For activity C, we can see the summation is 48 grand. And activity D is 18, and activity E is 28, and activity S is 40. So someone with a calculator handy, can you do a total budget for this job? So basically a summation of all this thing. Right, so very similar to drawing a bar chart, we will do a cash flow statement for this project. So 206 or 214, right, so we can see that, so it is 206. So let's (40, 32, 48, the 12, 18, 28, and 40. So there's a suggestion that the cumulative is 206. Okay, so we will do a weekly cash flow. So we know from our network diagram that the first two activities in this project are activity A and B, because C, D, and E cannot begin unless A and B have been completed. So A is a 4-week activity, and if we are scheduling on an early start time, the work will take place from 0 to 4. This would mean that our costs for activity A would be 10 grand for the first week, 10 grand for the second week. So basically I'm copying value from here, and 10 grand for the week 3rd, and 10 grand for the week 4. For activity B, it's you can see it's a 5-week activity, and the cash flow has been given in this table, and it would be 8 grand for the first week, 4. So it could be a nature of work. Maybe week 2 is not so intense. We are not producing that much, so slightly lesser cash. Week 3 is 8, and week 4 is 4, and followed by week 5, which is 8. Now we can see activity C would begin at this point after we have finished activity A, and for activity C it is going to be a 4-week activity, and budget for all of those 4 weeks would be consistent 12 grand each month. Right, so it's very similar. We are, rather than converting these things into a bar chart or a Gantt chart, we are using it to produce a cash flow statement. And activity E would begin after B has finished, which is at this point. And for E, the cash flow is 8 grand, 8 grand, and 12,000. And for activity D, we have 6226. So activity D depends on completion of both activity A and B, and it will be starting from week 6, and the budget for D is 6 2 2 and 6, so on and so forth we will do. Right, so this gives us the weekly budget for our project. So for week 1 of our project, in total we are receiving 18 grand. Week 2 we are receiving 14 grand. Week 3 we have a budget of 18. For week 4 we have a total budget of 14,000. And basically I'm just doing a summation of all the columns. And week 5 we have a budget of 20, and week 6 we have a 12 and 8, 20 and 26 in, and 22 in week 7, and 24 and 26 in week 8. So we will complete it. Next we have to do cumulative value. So the cumulative spend by end of week 1 would be just 18. By end of week 2 it will be 18 add 14, which will be 32 grants. So 3 and a 2. And by end of week 3 our cumulative spend on this project would have been 50,000. And by end of week 4 cumulative spend would have been 50 add 14, 64, and then 84, and moving on around 110 and 132. Right, so we would be doing a cumulative spend, and once we have the cumulative value, then we have to draw what is called a cumulative baseline budget. So if you assume that this is your y-axis, so by end of week 1 we are spending around 18. By end of week 2 it's about 32, just around here. By end of week 3 we have got a spend of 50. By end of week 4 our spend is 64. So I'm using these values as my y-axis, and then moving on to 84, just below 90 mark, then 110 here, and then moving on to maybe 130. So this line is very important when we talk about project management or project monitoring effort, and this is referred to as a PV line. Now in this example you have seen how do we draw a PV line, and this PV line serves as sort of like an anchor point for a project management effort to measure the costs. And once we are executing a project, we always compare ourselves. So if our project is so for instance, if my project is going like this, I can immediately see that I am overspending on my project because it's going much higher. Or if it is going much lower, then that may be a case of I'm underspending and I'm not producing enough output compared to what I have promised. So this PV line, or which is often referred to as a budgeted cost of work schedule line, is an important project management tool, which provides us with the anchor point to help us see how we are performing in terms of our cost. Now we will be coming back to this PV line, so it's important that you retain this in your mind, how we draw a PV line. Now we will talk a little bit about management of resources. So here we saw how we would be managing our costs, and we'll doing cash flow budgets. Here we will talk a little bit about the resources. So mind you, this is the pattern which we are following. So starting from the network diagram, learning about precedence diagram, then we learn how to do a forward pass and a backward pass, then we learn about the bar chart or a Gantt chart. You have just seen how we could use it for our cost planning and to draw essential PV lines. And now we will talk a little bit about how we could use it for resource planning. So here you can see the bar chart of our project, and different activities are shown here. The weeks are shown on the top, and you can see the bar chart has been loaded with the resources. So these could be 10 laborers working on activity A on the week 1 and 2, and activity B requires 8 and 6 laborers, and during the 3 weeks this activity will be executed. And activity C is a 2-week activity requiring 2 laborers in the first week, which is week 4, and 6 in the week 5. So what do we do is we do a summation of the total resource requirement per week. So for instance, in the week 2 we require in total of 18 laborers, and week 3 we require 8 workers, and then week 4 we require 10. And then we draw a resource histogram or a resource unit aggregation chart. So on the y-axis we are showing this thing here. So having a look at this resource histogram, would you have any concerns, or would you think that there is something which we could do? Would you think it's a good resource histogram, or needs some improvement? So when it comes to resource histograms, or particularly, for instance, if we are dealing with workers, we do not like to see too many peaks and troughs, right? So you could be dealing with your workers, and how would you manage it? There is a very steep. So in week 2 you require 18 workers, and then are you going to fire them, and they will be just sitting idly for the week 3, because you're requiring only 8, and then week 4 also. So from a week 3 there's a bit of a but there's a very certain peak demand. So basically we do not like to see too many peaks and troughs. Rather we would like to see a more leveled resource profile like this, right? It could be heavy duty equipment and machinery, so you can't bring your JCBs and CATs only for 1 week. You have to pay mobilization charges, expensive. So the suggestion here is try to avoid too many huge peaks and troughs, and maybe you can make use of the knowledge of the float to try to achieve a little bit more leveled resource histogram. So we use a technique which is called resource loading or resource aggregation, which is essentially a summation on a period by period basis of the resources required to complete all activities, and results are shown as a histogram, which you can see here. Now there are different types of resource leveling techniques which are used. Now in real life situation we work with projects with fixed amount of resources, so we have to prioritize which activities would get a resource, and so for that there are different resource leveling techniques which are used. So all resource leveling techniques essentially they delay a non-critical activity by using positive slack to reduce the peak demand. So we try to achieve a more leveled resource profile, and the way to achieve is by delaying the non-critical activity by using the positive slack. And we will try to fill in the valleys for the resources. We do not want to see too many huge peaks and troughs and valleys within the resource histogram, rather a more smoother resource profile. So resource leveling or resource smoothing involves attempting to even out demands on resources by using a slack, which basically involves delaying the non-critical activities to manage resource utilization. So here you can see an example. So in the solid black, you can see the resource requirement for the early start. So if you plan your activities for an early start, and this is your resource requirement chart, you can see here you have got a bit of a peak between in this area, so bit from week 2 to 4, and also then you have got a slightly bit of a peak starting from week 9 to week 12. And then that's one way to plan your resources, and the other extreme is that you plan all of your activities on a late start date, which is shown by a blue dotted line. So if you do that, basically your project is very sensitive because you're eating up all the float to start with. However, you can see the resource histogram, which is resulting from the late start, is slightly more leveled than the first one. Here you can see for the initial weeks it has remained consistent, and then from week 9 to 12, even though there is a peak, but there's a consistent peak for quite a few weeks. And then in the solid background is indicated resource requirement for activities on the critical path. So it is in a solid background because there's nothing much. This is cast in stone, and this is critical, so you can't do anything about it. So basically the early start and the late start provides you with two extreme options of managing your resources, so you can see what suits your project. So again, this is very much a quadrant 2 thinking, referring to Stephen Covey's matrix, where you have to maybe explore with your project team as to what is possible, which and what would be the best strategy to manage the resources. Now, different projects have different requirements. For this building, the only brief which was given by a client was one statement, and they told the project designers that they want a building which has never been constructed before and which could never be constructed again. So they wanted a flagship building, national pride sort of a thing. So for this sort of a client, resource was not a problem. But that's not a typical project. In most of the projects which we would encounter in our working life, the time and cost would be constrained. So we often would deal with different sort of constraints in the projects. First, most typical is an example of a time constraint project, a project that must be completed by an imposed date. So here the time is fixed, and given the time is fixed, you have to deploy more resources to ensure that the time targets are met. Additional resources may be required to ensure project meets schedule. So for instance, for a lot of retail construction, they want to hit the Christmas season, and they would like all their construction ongoing activities to be completed maybe by September, or so they could attract the Christmas shoppers. So they may have to throw in additional resources, maybe ask contractors to work double shifts or triple shifts to ensure that their project is complete by the time that they want. So if the time is the big constraint, then very often we have to throw additional resources. The other is an example of a resource constraint project. This is an example of a project in which level of resources available cannot be exceeded. So resources are fixed, and that's why we have to maybe compromise our time dimension. So inadequate resources will delay the project. So it may be a situation where you require maybe the Caterpillar machines on your project, and you have got only a limited number of machines, or maybe just a few cranes available to you. So everything would be centered around that resource, and as a result, your project timeline could exceed. And the third constraint which we often encounter is the physical constraint. You cannot ask too many contractors to work in a single room since the space is limited. Also, things like when you're working on a ceiling, it's a very small area, cramped up. So that's another constraint that we have to. So we do plan our work keeping in perspective these constraints. Yes, so that's correct. We could essentially end up with time and resource constraints in a lot of different situation, and there comes a time where a project manager has to take a decision as to where what their key priorities are, and which one they would be compromising or which one they would be going for. So if resources are limited, then obviously this has a knock-on effect very often on the time dimension. Or we definitely, if we want to achieve the time, then we have to bring in additional resources, or we may have to ask our contractors to work double shift, which may mean that we may miss our cost targets. So in a time constraint projects, the projects have to be completed by an imposed date. It requires the use of leveling technique that focus on balancing or smoothing resource demands by using a positive slack or delaying non-critical activities to manage resource utilization over the duration of the project. And in a time-constrained resource leveling, your peak resource demands are reduced, and resources over the life of a project are reduced, and fluctuation in resource demand is minimized. Right, so here we take a simple example to clarify things. Let's see the bar chart at the top, and we start by plotting a resource histogram of this bar chart which is shown. So let's assume we require certain pieces of equipment. Let's assume it's a backhoes which are required. So in this project, let's assume that's 1, 2, 3, and 4. So the design activity doesn't require any machinery, so it's not a problem. The layout and would require 2 backhoes. So our resource histogram would look like this during this period, and from week 4 to week 10, we would be requiring 4 backhoes, as you can see, and then it goes back to 1 backhoe, and from here onward, we will be requiring 3 backhoes. Right, so now let's put maybe a constraint that this was your initial resource histogram, but maybe you are informed that no, because of maybe a site constraint, you cannot have any more than 3 pieces of machinery available to you. That is the ultimate limit. You can't bring in 4 pieces of heavy machinery onto the site. That will make it very risky or whatever reasons. So just work with this. So if you are given this sort of a constraint, how do you think we should be address that. So obviously we have a problem in this zone. We have been asked to trim it down as we can just have only 3 pieces of machinery available. Okay, so I think we can't move it to the first week because that will defy the logic, because we have to, the arrows are basically showing the logical relationship. So I think that, so we can first of all start by looking at this is the float arrows. So this is something that you have to keep in mind. You have got a little bit of a leeway between these two. So I think the suggestion could be that if we move, maybe for instance, this activity here, we could have a very nice looking smooth resource profile. So I think if we do that, our new resource profile, so let's move this activity from here to here. Let's make use of this time. So if we do that, my new resource profile would look like this, and then over here it will be reduced to 2. So and then as I have moved fencing and wall activity later on, it will be a nice looking leveled resource profile. So you can see that this will be good because I don't have to bring in equipment. It's a very leveled profile. I'm keeping the machinery which I have brought in. Very often we have to pay mobilization charges for bringing the equipment to the site. So we don't want to bring them on site and then just dispose it off the next and then bring it after 1 week. So I think this may be a good option for us. And at the same time, we have not exceeded the sorry, this is the final line. So we have not exceeded the project deadline, but just by using the float, we have been able to manage the constraint which has been given. Right, so this was an example of where we have not jumped the time, but just by using the float, we managed to manage our resource constraint. But there could be an issue with the resource constraints. Projects that involves resources that are limited in quantity or by their availability, and scheduling of activities require the use of heuristics or a rule of thumbs. So most of the time we would be just using the software, any project management software, and we will be assigning resources to our tasks, and then we will give a command to our software to do the resource leveling for us. And usually the software use these heuristics while they compute the leveling. So first of all, and the software will give preference to an activity with a minimum slack. Secondly, the software will give the preference in a resource allocation to an activity with the smallest or least duration. And thirdly, the software will prioritize activity with the lowest activity identification number. So these are the heuristics which are used by most of the software. And this method is called the parallel method, which is used to apply the heuristics. And a parallel method is essentially an iterative process that starts at the first time period of the project and schedules period by period any activities scheduled to start using the 3 priority rules. Okay, so I think we have covered this, and there's a resource demand leveling techniques for a time constraint projects. The issues are there's a loss of flexibility that occurs from reducing the slack, and there's increase in criticality of all activities. And software use activities with most slack to level project resources. So just a reminder, these 3 rules that we have reviewed, these are important. So you can keep a quick note of them because we may need to refer to this these rules as we do a quick problem to demonstrate. these key principles. Right, so let's assume this is the project network diagram, which is shown on the top. This is from Gray and Larson's book, the project management, the managerial processes. So this calculations happen for you. So activity A. Now here, one thing you have to note is that the middle box here is telling us the resources, and activity A requires 2. So let's assume that this is some equipment or machinery which is required. So for instance, we may require Caterpillar's machinery on our site. Activity C requires 2, D requires 2, E, and so on and so forth. And also you can see here in this chart, we have been told that we cannot bring more than 2 Caterpillars on our site. It may be because of site constraints, or it may be because of cost factors, but we have been told maybe by our safety manager that that's the maximum number of machines which are allowed to operate on a site. So we have to schedule this project keeping in perspective the resources that are available. So here we can start applying this the resource constraint scheduling, which we have been reviewing in the previous slide. So here you're being asked to jot in early start. So for instance, the early start for activity A is 0, and the late finish for activity A is 2. So these are two extremes, and the slack for activity A is 0 as well. For activity B, the early start is 2. The late finish time is 5, and the slack is 2, and so on and so forth. You can complete. For activity C, the early start is 2, and the late finish is 5. And the slack is 0. Right, so let's start scheduling our resources. So we can see that the very first activity which is taking place is activity A, which is taking place from week 0 to week 2, right? And this activity requires, by the way, 2 pieces of machinery. So we will be scheduling this activity here, and there's no problem with that. Now we move from here to activity B and C. So once we have finished work on A, we can begin work in B and C. Here you can see the Gantt chart, which is shown here, and the early start is 2 and early finish is 3. So B could potentially take place, and the resource required for B would be 2, and the resources required for activity C will be 2 as well. So here you can see from this Gantt chart, this project was supposed to take 12 weeks to complete. However, given we have been given a resource constraint, we will have to explore the new duration of this project. But now we can see here the resource schedule for week 3 is 4, which is not possible. So what is your recommendation? What do we do? Which of the 2 activities shall we prioritize, B or C? So yes, if you recall, the heuristics were that you have to prioritize activities with the minimum slack. So here we have to compare B versus C. The slack of B is 2, whereas the slack of C is 0. And our heuristics guide us that the activity with the minimum slack should be prioritized. So this is the activity which has to be given a preference. So this is now very clear that we can't begin activity B. Now that's very clear that D cannot begin unless B has finished. So B has to take place after C has finished. This means that the early start time for activity D, which was previously 5, has now been moved to 6, and obviously that would go to 7. So once we have finished activity B and C, we can begin work on activity D. And activity D, as you can see, is only a 1 week activity, and it is requiring 2 resources. So that is pretty simple. So rather than working here in the previous case, now we will be working on activity D at this point. Right, so once we have finished work on activity D, then in principle, we can begin work on activity E and F. Now, mind you, the early start for activity E, which was previously 7, is not possible. It has now become sort of like a 7, and this would become 9. And likewise, the previous start was 7, now it cannot begin until week 7, and as it's 3 days, this would be. Right, so we have to choose between activity E and F, because in principle we can schedule both. Activity E is a 2 week, and activity F is requires 1 resource. Right, so what do you think, which activity shall we give a preference? Obviously we cannot work on both these activities simultaneously. E and F are giving a resource overload. So shall we prioritize E or F? So there's a suggestion that we prioritize E, again using the heuristics. Now the first of the heuristics is give priority to activity with minimum slack. So we have decided to go with E, which means that unfortunately F is not taking place here. So after each, we have to go through iteration again. So that is clear. Now once we have done that, then we have a choice. Either we could begin work on activity F or G. Mind you, the early start has already changed. Whichever option we do, okay, I don't know what happened to the annotations, but right, so I think we were here in a situation where we had to prioritize either activity G or F. So right, so I think one thing has to be, if I recollect, we were finishing this by 9. So activity G would have a okay, give me a second so I can work out the issue with the PowerPoint. So right, so basically the for activity F, the new early start time would be 9, and for activity G, early start time would be 9 as well. Now, once you are calculating the slack, you have to see that the difference 7 take away 9, because F is already being too much delayed. F would give you a lower slack when you take into account that the new start time is 9. So it would be -1, and here in this case F would be given a slack of -2. So F would be given preference when compared to G. And then once you have completed F, then you would go for activity G, and then so this is how your final solution may look like, where you would work on activity F, and then you would work on activity G and then H. And as a result, this project, which was originally supposed to complete in 12 weeks, will now be completed in a 16-week period. Right. So just as an experimentation, if you want to explore, you could take it to Microsoft Project or project management tool of your choice, and maybe see how this manual solution compares with the resource leveling which you get from here. But I hope you understand the final point which was made, that between activity G and F, mind you, when we are calculating the slack, we have to get based on yes, Microsoft Project is available through the university license, and for Primavera, I don't think so. We have got it available, so you can experiment with that. So the point I was making was, in comparison between F and G, F should be given a preference, because you have to take into account the new early start time, and that was 9. So 7 take away 9 gives you -2 slack, which so that's why we give preference to F. And once we have done F, then we move on to G. Right. So we did talk about that we don't like to see too much of a resource imbalance, and we don't like to see too many peaks and troughs within our project. Now here in this problem, you can see that activity C is a big trough. So for instance, if this may be a case of a heavy duty equipment on your site, and by week 0 to 4 you're using 6 pieces of machinery, and in week where you're doing C, and you're just using on week 6 just 1, so 5 of your machinery are sitting idly. They may be incurring a lot of costs. So what are your thoughts on this? How could we try to address this resource imbalance and this fluctuation? And then from the following week, it goes on to 7 resources, right? So 6, and then moving down to and then moving up back to 7. So any thoughts, any suggestions on how we could maybe sort out this problem with activity C? Right, so here we can see that there is a so you may have to discuss with the subcontractor of activity C and explain the situation to them. Sometimes it is possible to split an activity, maybe do it in different phases. So it may be possible if we can maybe see into 2 parts. If you're thinking of it as a Lego bricks, just doing this part, and if possible, splitting it and moving it to this part of our project to see if we could get a better resource profile. It may not be possible, but it may be possible as well. So this is something that has to be decided with the subcontractor. So the decision made here, if in possible, we have spoken to contractor and they have given us a green light that, well, be able to split it into two different phases where they will be completing the first phase from week 4 to 5, and then the leftover work would be completed 9 to 10. That would give us a much more smoother resource profile and will save 5 pieces of our equipment just lying around gathering dust in the week 5. So we can see here that the strategy used was to split an activity C from a large activity into two small sub-activity. So this is one strategy which could be deployed. Splitting or multitasking is a scheduling technique which is used to get a better project schedule and or increase the resource utilization. It involves interrupting work on an activity to employ the resources on another activity, then returning the resource to finish the interrupted work. So is feasible when startup or shutdown costs are low. So again, this is something which has to be done in consultation with the contractor who is leading the work on this activity. And it's considered a major reason why projects fail to meet schedule. Now, sometimes there is a misunderstanding that people think that, well, basically you have got this big, huge activity without splitting, and you could split it into 3 clear segments, and it would take the same amount of a workload or effort. This is not the case. Very often there is a shutdown and a startup involved, so you demobilize an activity and then you are restarting. So if you are splitting an activity, it would not mean that you end up with the same workload. Perhaps your workload would increase because you have got a shutdown and startup costs involved. And then again, when you begin the work on the last phase, you again have to mobilize your activities. So this may cause the overall duration of your activity to increase. Right. So I think now I did mention that as part of your course assessment, students are expected to do some of the problems themselves. So this is one of the problem which I would like students to explore on their own, and this has to be submitted towards the end. And I would like to see an evidence. We would be discussing this problem, so don't worry if you get stuck into this, but this may provide you with an opportunity to explore some of the concepts that we have learned in this session. So the scenario here is that as part of the UK relief mission, you have been deployed in an earthquake zone to help communities recover from a devastating earthquake. Community is without fresh water supply for over a month now, and your challenge is to manage construction of a tube well, a pump house to help the communities recover. The following method statement has been provided for the work that's to be undertaken. So the work involves the project will start by drilling of well. Once the well has been dug, you should start pump house construction, and then installation of pump should only be done once pump house has been constructed. So basically a method statement has been given to you, and the resources required has been given to you. And so basically you will have to manage your resources here. So hiring a single labor will cost UK taxpayers £150 per day. So you have to make sure the labors which are being deployed are carefully being used. Please ensure you optimally utilize the workers, and please assign workers to your project sensibly. Do not fire and then hire and then fire again. So this idea of having too many peaks and troughs in your project should not be done. So what I would like you to do is reflect on this statement. Don't worry too much and do not spend too much time on this. We will be discussing a possible solution to this. So if you have some time, maybe, so I will be sharing it with you on the chat window. So if you have got time, you can explore maybe a possible solution, and then when we come back next week, we will be comparing your answer to the answer which is given. But I would like to see an evidence that it is every student has completed this problem and given it a go, right? So you can have a look at it. The first step for you would be to draw a network diagram based on the method statement which has been given to you. So here you can see the first activity is drilling of well. Then once the well has been dug, you should start pump house construction, which will be the second activity. So there will be a finish to start. Then installation of pump should only be done once pump house has been constructed. So trying to understand the logic, and based on this, draw the network diagram, which will allow you to do maybe a forward pass or a backward pass. If you want, you could use maybe Microsoft Project or a scheduling tool of your choice. Then you would identify the bar chart. Once you have the bar chart, then you will load this bar chart with the resources required. And once you have the resource, then you would have some sort of like a resource aggregation, and you will see what is your resource profile looking like. So the sponsors don't like you hiring and firing people, so you have got 15 laborers working for you one day, and next day you decide to just work with 8. That is something which the sponsors will not positively look at, because what are the 7 workers going to do sitting idly? So your challenge would be to keep your workforce busy using a smooth resource profile, right? So I will leave you with this task, and we will revisit it next week. So as I said, I do not expect you to spend too much of time. Maybe you can just give it a go, try to do it. We will discuss solution. If you have got some time, you want to explore it, that's well and good. But if you're very busy, then have a small 15-20 minutes reflection on it, draw basic, and we will discuss the potential solution to this when we meet next week.